Okay, here's Unit 10, Lesson 1 and 2 review. So we want to state the exponential function for the following. So population of 7 turtles, so 7, and it doubles every year. Okay, so my exponential function would be y equals, and I'm going to have, it starts with 7, that's my a, times doubles, that's the 2, and to the x. All right, so enough of that. All right, so now for the second part, it says, based on this information, what is the turtle population in 25 years? Well, I would say y equals 7 times 2 to the 5th. Okay? How do I get 5th? Well, it doubles every 5 years, and x is the number of 5-year periods. So how many 5-year periods are there in 25 years? So 25 divided by 5 equals 5. That's where this 5 came from right there. So when I do that, that equals 7 times 32. I can do that straight on my calculator, and I'm going to get 224 turtles. Okay? All right. So let's look at 3 and 4. Population of 2 cockroaches. So 2 cockroaches, and they triple every 4 months. X is the number of 4-month periods. Okay? So state the exponential function. So it's going to be y equals, since there's 2 cockroaches to start, it's 2 times triples, the b is going to be 3 to the x power. So that's the general exponential function. Now I'm going to find out what the population is 3 years. Well, 3 years, how many 4-month periods is that? Well, there's 9 4-month periods in 3 years. Okay, I can do that by saying there's 36 months in 3 years divided by 4. That's how I get 9. So I say y equals 2 times 3 to the 9th, and I put that in my calculator, and I get 39,366 cockroaches. Okay? All right, write the exponential functions that's represented by each of the tables in numbers 5 and 6. So here, well, like we said, we're always going to circle this part right here. When x is 0, y is 1, that's an important. That's my starting value. That's my a. Okay? So I know my a is 1 from that. Now my b, that's how do I get from 1 to 1/4? Well, I multiply by 1/4. Or if I go backwards here, how do I get from 4 to 1? Multiply by 1/4. 1/4 times 1/4 is 1/16. So my b is going to be 1/4. Okay, now that I know that, I just put it in there. Y equals 1, that's my a, times 1/4 to the x power. Okay? Once again, my a in number 6 is going to be 16. My b, well, that's how do I get from 1 to 4? Multiply by 4. Does it work throughout the other whole table? 4 times 4 is 16. 16 times 4 is 64. 64 times 4 is 256. So my b value is 4. Once again, we're plugging it into y equals a b to the x. That's my general form, okay? So y equals, my a is 16, times 4 to the x power. Okay? All right, let's move on. Identify the function represented by each graph in number 7 and 8. Okay, so this is increasing, right? So increasing has to be a whole number. I know that it can't be a fraction as a base. Can't be that one, and it can't be that one. Okay? So now I'm going to look. If I put 1 in, when I put x equals 1, what do I get? Well, I get 4 to the first, which is going to be 4. So when x is 1, y is 4. That's when that one did. What about when x is 1 up here? X is 1. I get 3 to the first, which is 3. So I get 1, 3. Well, which one looks like it's on the graph? Definitely the red one. This is definitely the answer. Okay? So once again, this is decreasing now. So I know that it can't be an increasing exponential. So I'm going to cross out those whole number bases. It's got to be a fraction. And I would put maybe 1, or maybe let's put -1 in. Might help us out a little bit more. X equals -1. I get 1/5 all to the -1, which means it flips over and it gets 5. So at -1, I get 5. Okay? Well, what about when I put -1 in down here? 1/4 to the -1 is just going to be a 4. Well, it looks like this one is the correct one. That's the one that matches up with that graph. Okay? So 9 and 10. Let's look at 9 and 10. Plot at least 5 points. So we want to make an xy. We can put in our calculator that function. We want to plot a few points. This one says plot at least 5, so we can go maybe, we'll go -2, -1, 0, 1, and 2. Okay? When I put -2 in there on my calculator, when I put 0 in, I get -2. Whoops. 1, I get 1. When I put 2 in there, I get 13. That's going to be off the graph. When I put -1 in there, I get, I'm just going to keep it as a fraction, so I would get 1/4 minus 3, so it would be -2 and 3/4, or -2, -2.75. Okay, -2, I get negative. When I put that in, I get 1/16 minus 3, which is going to be 2 and 15/16, negative, sorry. We can get the decimal, but it's going to get really, really close to -2. So I'm going to plot these points. I'm going to start with 0. At 0, I get -2 right here. At 1, I get 1. At 2, I get something way up here at 13. I'll go back now. At -1, I get -2.75, so it gets close. It starts to get closer, but it's never, ever going to cross -2. Okay? Same thing over here. We're going to do an xy, plot some points. Let's say -2, -1, 0, 1, and 2. Well, at -2, I get 2.5. At 1, let's pause. We're going to pause this right here.